As we wrap up the 3.3 notes here, just a couple of little reminders about imaginary numbers. Remember that I stands for the square root of -1, and therefore I squared is the square root of -1 squared. Now remember, squaring and square rooting would cancel out and leave us with just -1. So remember that every time you see an I squared, we can replace that with a -1. Just kind of keep that in the back of your mind, okay? Okay, some operations or doing some calculations with I. I is a number, but we treat it a little bit like a variable in terms of calculations. If I were to distribute this 4, I would get 12 plus 8I, okay? And if I were to multiply 3 plus 2I and 3 minus 2I, I would FOIL those together. 3 times 3 is 9. 3 times -2I is -6I. 2I times 3 is positive 6I. And 2I times -2I is -4I squared. Now, keep in mind, in that FOILing process, you always have to check for like terms. Notice that -6I and positive 6I cancel out. So that leaves us with 9. And remember, I squared we said was -1. So this really means -4 times -1, which is a positive 4. So that would give us 9 plus 4, or 13. Now what's interesting about that is, remember, if you multiply two conjugates together, complex conjugates, you're going to get a real number answer, okay? That's why sometimes in these quadratic equations, like we just looked at a while ago, sometimes these quadratic equations have imaginary zeros and they don't touch the x-axis. We didn't see anything about this that looked weird or strange. It's a regular old quadratic, and it has to do with the fact that when you multiply those conjugates together, you get real numbers, okay? All right, so they say, hey, use the remainder theorem to show that 8I is a 0 of this function. Now notice this polynomial is degree 3, meaning it's going to have 3 zeros, okay? And they are telling us that 8I is a 0. Well, we know that if a number is a 0, that means x minus that thing is a factor, which means that if we did synthetic division with this thing, we should get a 0 remainder. So notice if I'm going to divide by x minus 8I, then I'm going to put an 8I, a positive 8I, in the box. So 2, 1, 128, 64. Okay, we're going to do some synthetic division here. Bring down my 2. 8I times 2 is 16I. Combine these. They're not like terms. 16I and 1, they're not like terms. I'm going to put 1 plus 16I. I wish I'd spread these out a little bit more, because they're not like terms. But now I can multiply 8I times this thing and write it up here. Well, 8I times 1 is 8I. And 8I times 16I, well, 8 times 16 is 128. Okay, but it would be 128I squared, because I times I is I squared. I squared is -1. So really this would be a -128. When I combine these two together, 128 and -128 cancel and leave just 8I. 8I times 8I is 64I squared, but I squared is -1, so this is really a -64. 64 and -64 are 0. So notice when we divide by x minus 8I, by putting 8I in the box, we do get a remainder of 0, okay? Which that was expected because they told us that 8I was a 0, okay? We just verified that by finding that the remainder was 0. Now notice, since 8I is a 0, 8I is imaginary. So 8I and -8I are both zeros. Okay, so we know that -8I is a 0. Now, one more thing about this. That exponent is 3, which means there are 3 zeros. We know 2 of them. One of them's 8I, one of them's -8I. We don't know what the other one is, okay? We'll work on that more in 3.4, but we know that these two are zeros. Okay, another problem here, number 14. Find the zeros of this function given that -5 is a 0. Now notice the degree is 3. That means there are going to be 3 zeros. They're telling us that this is one of them. Negative 5 is one of them. If negative 5 is a 0, then x plus 5 is one of our factors. Okay? We don't know what the other factors are, but x plus 5 is one of them. Since x plus 5 is a factor, negative 5 is a 0, I can put negative 5 in the box and do my synthetic division. So 3, 25, 42, negative 40. Do synthetic division. Bring down my first term, multiply by the box, combine, multiply by the box, combine, multiply by the box. Sure enough, we get 0 as our remainder. So 3x squared plus 10x minus 8 is our depressed polynomial. Okay? Notice I knew it was an x squared because the original had an x to the third. Okay? If I set that equal to 0, now I have a quadratic. This thing will have 2 zeros. Okay? I can try to factor. I'll just let you know this one's not going to factor out very nice. So we're going to do a quadratic formula. Okay? Remember quadratic formula. With a value will be 3, b is 10, and c is negative 8. We can plug those values in. All right, so x equals negative b. b is 10, so negative b is negative 10. Plus or minus the square root. b squared, well, b is 10, so 10 squared minus 4 times 3 times negative 8, all over 2 times 3. All right, let's work out what's under the radical. 10 squared minus 4 times 3 times negative 8. That works out to be, let's see, 4 times 3 times negative 8 is 196. Okay, so x equals negative 10 plus or minus the square root of 196 divided by 6. Okay. Let's see, 196 is, let's see, we can divide by 2. So 2 and 98. 98 is even, it'll divide by 2. So 2 and 49. Ah, look. We got a pair of 2's in there, and we got a pair of 7's. That means a 2 comes out, a 7 comes out, that's 14. You might have just known that the square root of 196 was 14, and that's fine too. So negative 10. Plus or minus 14, divide by 6. I'll work it once with the plus and once with the minus. Negative 10 plus 14 is 4. 4 divided by 6 is 2/3. Negative 10 minus 14 is negative 24. Divided by 6 is negative 4. Okay, so our zeros are negative 5. That's one they gave us. Positive 2/3. That's one that we found. And negative 4, which came from the quadratic formula. Okay, those are our 3 zeros. Negative 5, positive 2/3, negative 4. They don't ask us this, but remember if negative 5 is a 0, then x plus 5 was a factor. If negative 4 is a 0, then x plus 4 is a factor. And if 2/3 is a 0, then 3x minus 2 would also be a 0. I know the 2 had to be separate, opposite sign had to be negative with the 3 in front. Okay. If you wanted to graph it, 3x to the third plus 25x squared plus 42x minus 40. And when I graph it, sure enough, recording. Sure enough, our graph hits the x-axis at negative 5, at negative 4, and at positive 2/3. It's kind of hard to tell if that's a 2/3, but it is. Okay? But these are our zeros right here. Okay? Number 15 right here. Here's our function. They say find the zeros given that x minus 6 is a factor. Well, if x minus 6 is a factor, that should mean positive 6 is a 0. So I can do synthetic division with 6 in the box. So 4, negative 24, negative 3, 18, negative 1, and 6. Those are all my coefficients. Do my synthetic division. sure enough, we get a remainder of 0, which we should, since they told us that x minus 6 is a factor, so positive 6 is a 0 and has a remainder of 0. Now, notice what we're left with here. We're left with 4x to the 4th. I know it's to the 4th because this was an x to the 5th. This is a depressed polynomial. They've got some zeros in there. So this negative 3 is for x squared, and this negative 1 is my constant at the end. Okay? I can set that equal to 0. This is a hard one to factor. Don't stress about it too much. I'm just going to let you know that it factors to 4x squared plus 1 times x squared minus 1. I don't expect you to necessarily know that that's what that factors to. I can't quadratic formula because this isn't a quadratic. It's raised to the 4th power. Okay? Once I get to this point, I could factor this part again. I know x squared minus 1 factors to x plus 1 and x minus 1. Okay? And if I set this part equal to 0, the 4x squared plus 1, if I set that equal to 0, I can minus 1 on both sides. 4x squared is negative 1. I can divide by 4. X squared is negative 1/4. And when I take the square root, I would get 1/2, because 1/2 times 1/2 is 1/4. But I have to put an I on it because you can't take the square root of a negative. And imaginaries always come in pairs, so it's positive 1/2 I and negative 1/2 I. Okay, so notice that the zeros, there are 6 of them because, I'm sorry, there are 5 of them because this is raised to the 5th power. One of them is positive 6, that's the one that they gave us. One of them will be negative 1, it's come from the x plus 1 factor. One will be positive 1, it comes from the x minus 1 factor. One will be positive 1/2 I, and the other will be negative 1/2 I. But there are our 5 zeros right there. That one's a little tricky because the factoring. Don't let that throw you. I probably wouldn't ask you to do that one that complicated on your own. Okay? And then 16, here's another way to kind of piece all that together. Write a polynomial of degree 3. So that means we're going to have an x to the 3rd in it. If the degree is 3, that means there will be 3 zeros. Okay? And it has zeros of 2 with a multiplicity of 2. So 2 with a multiplicity of 2, that means that 0 gets used twice. Well, if 2 is the 0, then x minus 2 is the factor. And there are 2 of those because they told us the multiplicity was 2. And the last 0 they say is negative 5. Well, if negative 5 is the 0, then x plus 5 is the factor. So I know that these are the 3 pieces that multiply together to produce our f of x function. If I FOILed it all out, there would be an x to the 3rd. 2 is used twice because x minus 2 is used twice. Negative 5 would be used once because x plus 5 was a factor. And you can FOIL that out if you want to, or you could just leave it in factored form.